And today I'll be explaining you the implementation of the context monitor application. So this context monitor application is a basic application that collects data from various sensors such as camera and accelerometer, and then the data collected is fed into the algorithms to compute the heart rate and respiratory rate respectively. This app also allows you to store the symptoms severity levels that the user feels, and all the data is stored in a local database which is created using the RoomDB SQL interface for the Android application. So this is the folder structure. Now these are the Gradle scripts. Here you can specify all the various libraries or the modules that you need. So like I've used RoomDB, then the Camera X API, so other functionalities, and the Material 3 library. And you can specify the versions here. Either you can do this way or you can directly specify it for it to fetch the latest compatible version. Then this application is built for Android API greater than equal to 29. So that you can we can specify here. Then this is the manifest folder. So here I have specified the permissions that are required for the application to use camera. So that I've specified here, and these permissions can be directly fetched by a permission launcher in the which I've coded in the main activity file that I'll show later. And you can specify all various permissions here. As the app is built for Android API greater than equal to 29, so we don't need to explicitly write a request for external storage permissions. This was valid till Android Max SDK version 8, but this is a way you can write the code if you want to develop applications for lower versions as well. And you can specify other things, like you can fix the orientation here if you want, though for our application the orientation is not always fixed. And then you can specify the icon, path, and the label name of the application. Then this is the resource folder. So here I have created my custom logo for the application, and then I feed it into the image assets to create multiple versions or variations of the logo, like multiple dimensions. So the small, shell, big. So as you can see, these get loaded depending on the Android device and the uh, stage at which the logo needs to be used. It's like maybe when launching the screen or yeah. Then this is the values folder, and here I have specified all the pathologies of the symptoms, and these array will be directly fetched from here. So you can fetch it directly in the code itself, and I've specified the name here as well. So coming to the main code, which is inside this folder. So I've organized the code in 3 folders. One is storage. It handles all the data base related functionalities. Then the UI, the screens and the widgets. Utils are the common functions like the algorithms, and the main activity is the main file which we will run. So starting with storage, we have data converters. These are so like RoomDB does not support multiple data structures directly. Does not support to store multiple data structures or complex data structures. So what we do here is we create a data converter which converts our data structure into a JSON, and then that can be stored in string format by the RoomDB. Then we have data access object. So this is here we have coded functions to fetch records based on this query in descending order of recorded on date, and you can insert a new row as well. So this is the object, and this is the interface that we will be using in the code to communicate to the database or to manipulate the entries in the database. This is the data table, and here we have 5 columns. So the first column is the primary key to ensure uniqueness for all rows, then the heart rate, respiratory rate, and then we store a map of symptoms, and map stores all the pathologies and their ratings, and only those pathologies are stored which have greater than 0 severity level. thus saving space. And then we have the date on when the entry was recorded. And this is the main database table. And here I have specified, and this storage DB class is a singleton class. Also, you specify type converters here, and this will allow for the database to automatically convert specific types that get passed into the database, into the functions in the data access object. Now, the advantage of using singleton class is that it ensures thread safe initialization of the database, and you can directly use this object everywhere in the code without creating multiple instances of it. So like you don't need to create multiple connections with the database. Only one connection will handle all the communication, thus avoiding usage of multiple resources. Then after storage, we have the UI layer. This I'll come a bit later because this is the main part. Talking about utils, in utils you have the constants file, which stores all the constants that are used throughout the code. And here I've specified the 45 seconds that are needed. Then this is the heart rate calculator algorithm in which you pass the video URI and the content resolver to fetch the data and calculate the and run the required algorithm to calculate the heart rate. Similarly, we have a respiratory rate calculator which calculates all the which calculates the respiratory rate based on the acceleration values provided. Now to explain the basic functionality of the application. So the application requires you to measure respiratory rate by first the user should lie down and then he should place the mobile on his chest, and for 45 seconds he needs to take deep breaths to record the changes in the orientation of the uh, mobile which are in response to the changes in the chest movements. And for the heart rate, the user records a 45-second video in which he with the smartphone's back camera, and he places his index finger over the lens to cover the light from the flash, and the red coloration that appears in the preview view, the changes in that red coloration are used to calculate the heart rate as well. So this is the basic functionality. And then also for symptoms rating, the user manually enters what he feels is the severity level of the pathology that is being asked. Now coming to the main activity file, so this is the main file, and here we have so these are all the view models. Now our application has three screens. First is the main screen where you will see where you will record heart rate and respiratory rate. Then there's a second screen where you upload the symptoms, and then there's a third screen where you can see the past records of the entries that had been recorded. So talking about add symptom screen. So in this screen you have a box in the middle, and it shows the symptoms name, and on the right side it has a drop down icon. When you click on the box, a drop down menu will appear, and here you can select the pathology, and when you select the pathology, that names gets updated on the box, and the following rating is shown below it using this star rating bar. And you can select any rating you want, and it gets automatically updated here with this function run. So in star rating we have icons, and these icons have clickable attached to them, and when an icon is select icon is clicked, it will automatically run this function which updates the rating of that selected symptom. And if the rating is below the index value of that star icon, then then the icon is not filled, and if the rating is greater, then it is filled. So this is the view model, and here this is used to get the application context, which is then used to fetch the singleton storage DB, which is then used to fetch this class and insert an entry inside the data table. So this is just a basic function which inserts entry into that. Then we have the star rating I've discussed. So this is the main box that I was talking about, which has a gesture detector on it. So whenever you click on that box, the drop down menu will become visible. And whenever you click outside the box or you have clicked up one of the pathology, then the drop down will be dismissed and the expanded variable will be set to false. As you can see here, and expanded is just, it just tells whether the drop down is visible or not. Also, this is uh, as you can see, this is a scrollable state. So like if the UI, though for our case there are only 3 rows required, so the UI does not exceed the screen size in landscape orientation. But still, if the screen was small, the scroll state will allow for the UI to scroll if the screen size becomes larger than the required height. So this was the basic add symptom screen implementation. For the view symptom screen, we have a box, similarly a card, and this is also, and this is, here we use lazy column because we can fetch the records, we can fetch all the records, but lazily render them on the screen. So only those records which are visible or those widgets that are visible on the screen are rendered. Others are not rendered at the start only. They are rendered as a threshold is reached. So like if suppose only 3 boxes are to be visible on the screen, so it will suppose load 5. Not exactly, I'm just taking some example numbers, but it will load 5 widgets, though there are 10 widgets available, but it loads just 1 or 2 extra so that the UI experience is fine and minimum resources are used. In the card, we display a recorded on uh, when the entry was recorded, the heart rate, the respiratory rate, and for symptoms, if there were any symptoms recorded, like if any of the symptoms had a rating greater than 0, then they are displayed in a list with the rating value. Otherwise, we display no symptoms. And these are all displayed in a descending order of the recorded. So the most recent entry is shown at the top. Similarly, we use a view model here to get the database and fetch the records. And this display text is used for formatting how we display the entries here. Then we have the heart rate model and the respiratory rate model. So these are the 2 main files in which we have coded the functionality of the sensors. In heart rate model, we use Camera X API, and it has the advantage of this Camera X API is it has like various compatibility advantages, and it also provides with me various APIs that we will use in the code, so that I'll show you. So first is that we we, first we get a camera, uh, like the code registers a camera. Okay, we will use this camera. There may be multiple cameras in a device. It will register which camera to use. Then it will initialize a video capture. So we will provide a surface in the main activity. With on so here I provide the surface in this one. So this surface, and for this the surface provider is passed into this model, and this is what captures the camera. The camera captures the output of what is displayed here, and it display and then it binds to the life cycle. So till when the camera is required, or like till when the recording needs to happen, it will stay banded to that. You can bind it to the life cycle, and then once all the initializing is done, you start recording. And in recording, you have specified the file name location, so the format on how the file name will be saved, and we use media store here. So there are two popular APIs. So like one is media store, and the advantage of using media store is that it automatically handles the storage, the retrieval, the storage of the uh, video that we have recorded. We don't need to explicitly ask or request for permissions for storage. It directly stores the application in any media player app or gallery. And then we have a camera control API, and this camera control API allows us to control torch, the function, so till when it needs to be enabled or when we can turn it off. So all this happens programmatically with the help of the camera control API. Um, so we have a progress. Progress is an integer, and it gets updated from 0 to 45. So this is max progress. So what this does is, so once the recording starts, once the camera has been initialized and the recording starts, it will run a while loop, and in the while loop we have coded a delay function. So this will delay the execution for 1 second inside this dispatcher, and so like this won't impact the application working. It's like it will be running in a separate thread, and the advantage of this is, so because we need to stop for 45 seconds, so we delay for 1 second, that is 1000 milliseconds, and then the progress will get incremented by 1, and this will keep on happening till 45 seconds, because that is the time, till we need to record the video or the respiratory rate readings. And once this is done, it will call the stop recording, and this will release all the resources. As you can see, it will disable the torch, release the recording, and stop the camera, and unbind it from the life cycle. There's also this function handle video record event. So this is registered here, as you can see. So whenever the recording starts, there will be this as an output, and when the recording ends, it runs a function which is passed from the main activity file to this file, this model, and this function will update the video URI path in the main activity, which I'll show you later. And if there is the recording failed or it did not save the file, it will return null. So on video record is the function that we will pass from the main activity. And I can show it here. On video record is just a basic function. This is the on video record function. It just so once the collection of the data or the video capture is done and the file has been saved, it will set these values, and this will update the UI, which I'll explain a bit later. So this is heart rate. Similarly, we have respiratory rate. Here also we register sensors. So accelerometer will get registered here, and accelerometer and the sensors will get registered here. And if there is no accelerometer, we just output an error. And so it has main start accelerometer data capture, the main function that we will be using. So what happens is, we store all the accelerometer reading values in a mutable list, and a mutable list of float array, and when this function runs, it sets is collecting value to true, and this will update the UI or the values which are being listened in the main activity file, which I will show you later. And we also register the accelerometer to the sensor, and once the accelerometer is registered to this sensor, so whenever the sensor value changes, the accelerometer appends the new array and the new list, and the values that it appends is like the x, y, and z axis values of the orientation of the mobile device. And then we have so whenever this function is called, we will check if accelerometer is enabled or not, and then we'll check if it was already collecting, then it will stop the previous collection and clear all the values, and then it will start the new data collection. We initialize progress as 0, similar as we had done in heart rate model, and the same functionality is run here as well. And once this is done, once the 45 seconds are complete, the data capture is stopped and all the resources are released and the register, the the accelerometer is unregistered. Now, in each of the view model file, I had also coded a model factory because this is used in the main activity file as shown here. So this. So this is the main file, uh, which is like here we have coded the first screen that you see on the application that is coded here. Now the application has one feature, so we can fix the orientation uh, at certain moments so that consistent collection of data and calculation of the rates is done. This I'll explain a bit later. But for now, we have the scaffold, and inside the scaffold we have a navigation controller, and it has three screens, first, second, and third. So the first screen is the main screen where you will see the heart rate recording, the respiratory rate recording, and the other buttons. And this is second screen where you add the symptoms. So in this screen we specify the path as follows. So whenever uh, so this will so here we can like fetch the arguments that have been provided by the first screen to the second screen and pass it as follows. And if these are rates are not null, so for our particular application implementation, if the rates are not if any one of the rates is null, or then this snack bar will be displayed, indicating that incomplete data is provided because we need both the rates to be calculated for a successful entry. Then there's a third screen. This is basically the view record screens. Now, there was one thing that I wanted to show in the add symptom screen here as well. So as you can see here, I have used this whole code here. The basic use of this code is that so for my implementation, when the user has suppose calculated the heart rate, then the respiratory rate, then it clicks on the upload science button to be redirected to the second page, that is the add symptoms screen page. Here he selects the symptoms, rates them, and then when he click on upload symptoms, so he has completed all the process. So now he is automatically redirected to the first page because there is nothing else to be done on the second page. So once he's redirected to the first page, so for to implement that functionality, I have used this particular code. And if the user decided, okay, suppose he calculated both the rates, but when he went to the add symptom screen, he did not click on the upload symptoms button. He directly clicked on the back button to go back to make a few changes to the rates if he wants, or to recalculate the one of the rates. So if he wants to do that, then he can directly go back to the screen and he will see both the rates shown as it is, and both the rates values will be retained. But if the process was completed, then the rates value will be set to null because the entry has already been added. Uh, so this ensures uniformity in data collection process for the user, so that he don't uses the same rates for adding multiple adding different entries. So this is the code that I will, and here also in the upload symptoms, as you can see, if the button was clicked, then only it is set to true. Otherwise, it is not set to true. And we also set it back to false here so that multiple triggers are avoided. There's one more thing that we are using remember savable at most places. This is because our application is compatible to various orientations. So if you change the orientation in between, the code would not crash, or the values stored in the state variables would not be lost or destroyed. Then we have a permission launcher, so it handles all the permissions required for the application to run, and this basically checks the Android manifest files and gets the list of all the permissions that are needed. and then it will check whether if the permissions are provided, then it will display okay, the permissions are granted. But if they are not provided, then uh, it will like just show a toast saying required permissions are not granted. And this only gets, so for we only need this for camera, so that's why I've coded this in the camera button, uh, as you can see here. So whenever you click on the heart rate calculation, it will automatically first check whether permission for camera is provided. If it's not provided, then the permission launcher launches the dialog box where in which you can see while using this app, provide the permission to this camera app, camera feature while using this app, or when only this time, or don't allow it. If you don't allow it, it will display permission for granted and it won't calculate the heart rate or enable the camera. Otherwise, if it's already enabled, it will set collecting heart rate to true and it will initialize all other variables. Now we also use is so for this code I have used is calculating is collecting for both heart rate and respiratory rate separately, RR and HR. What this does is, so when the user is collecting data, he will see text display of collecting, and a circular progress indicator is also used uh, to provide them feedback of like how long it has been since he started recording. So this runs for like 45 seconds based on the progress value which is fetched from the view models, as you can see here. And yeah, so is calculating will display calculating. So this is the display which will happen when the algorithm is running to calculate the value of the rate, and is collecting is set to true when the application is collecting state when the data is being collected. So this helps to provide feedback to keep the user informed. So as you can see, when is collecting is true, recording, otherwise calculating. And if once everything is done, it will display the rate. And if there is no rate to display, it will display not measured yet. Now we have launched it. So video URI. So whenever the video URI value gets updated, this function will run, and this will basically set to calculating HR to true, and then it will calculate the heart rate by this function that I coded in the utils file. And setting calculating HR equal to none means everything is done. Uh, yeah. And this also avoids multiple re-triggers of this function. So if because video URI is changed, then it won't re-trigger this function again and again. So it gets stuck in this loop if you don't provide this here to stop the re-trigger. Then yeah, as I was talking earlier about the orientations in the top. So in our application, we generally fix the orientation once the user starts collecting data and the calculation happens. This is done for consistent calculation or for more accuracy. Yeah, so for this, we just fix the orientation once it is in collecting or calculating stage, and release that once the user is able to navigate to various features. Also, in this implementation, I disable the buttons when the user when the data is being collected or calculated, when the rate is being collected or calculated, to avoid any side effects that might happen while running this application. So for the collection part, so we have an Android view here, and this will display the video, or this will display the capture, the real-time capture of the camera to give a better view or better insight to the user of what is actually captured, so that he can perform the activity accurately. And when the collection is stopped, you will see a black box being displayed. This saves the resources. Similarly, and yeah, this enable is being added for all the buttons. These are disabled based on these conditions. Then there's a third button, which is the upload sign. So this will take it to the next page. and we have specified the path as follows, and this will be recognized by the navigation controller, and then it will redirect it to the second screen with these variables coded in the screen, coded in the path. And finally, we have the view past records button. This will redirect it to the third screen. Yeah, so thank you.